chance for them to do that. Okay, Caleb, how are you doing today?
I'm doing very well. How are you?
Good. Now, Caleb, or both you guys, this is our last recorded session. After the AP test, you guys are done. Stop what you're doing. Now, I have like a final exam and everything. No final exams this year. Okay, you're done. You can go back and do anything if you want to retake something to bring your grade up. You absolutely can do that. But after this week, there's no new material. So next week, I would say that maybe study, but by Sunday night, stop. Do not do any more work. Monday, relax. You can study too much, and your mind goes blank. So just after Sunday, just step away from the math, and then Tuesday is the test. And I think I have I didn't put that slide in here. Darn it. I wanted to talk about the test. I'm going to go back into, I think I had it in the weekly announcements, didn't I? No, okay, so let's see here. So the exam is at 1 o'clock on Tuesday, May 12th. You'll have 25 minutes to read and respond to, and you guys got this, right? How many, like there's 2 questions on the exam. One's 25 minutes, one's 15 minutes.
Yeah.
Okay. Yeah. And they're both, obviously, it's a free response. They're both, you can use calculator. So today what I want to do is I just want to go through, just review what we did last week. Taylor polynomial of degree 3. Now, Henry, I think you were making some mistakes on this last week's assessments. That's why I wanted to go through these two problems.
Yeah, actually,
okay, go ahead.
I actually had a question on interval of convergence. I was working on 12C this morning.
No interval of convergence on the exam. Okay. Cross that problem off. Don't need to do it. Anything that has an interval of convergence, not on there. Do you need to know Maclaurin and Taylor series? Absolutely. Okay. So when it's centered around 0, when A is 0, we call that a Maclaurin. It's a Taylor series, but it's a special type because it's around 0, so we call it a Maclaurin series. This is the formula. It's f of 0 plus f prime of 0 x plus f double prime of 0 x squared over 2 factorial. Now I could have put this over 1 factorial because it's x to the first, but 1 factorial is just 1, so we really don't do that. Plus f prime of 3, 0, x to the third over 3 factorial. Now, it said degree 3, so I have to go all the way out to the 3rd degree. Now, if they said 3 terms, then I would have just did 1, 2, then I would have just did these 3 here. But it did say degree 3, so I have to take it all the way out to the 3rd degree. So the first thing I would do on a problem like this is you have to know what f of 0 is equal to. Well, I just put 0 in here. 2 times 0 is 0. Sine of 0 is 0. I need to know what f prime of 0 is equal to. Well, then I take the derivative of this. That's cosine of 2x times 2. So that's 2 cosine 2x. Put 0 in there. That gives me cosine of 0, which is 1. 2 times 1 is 2. So now I know what f prime of 0 is equal to. Then I need f double prime of 0. Well, if I take the derivative of this, what do I get? Negative 4 sine 2x. Well, if I put 0 in here, the sine of 0 is 0. Negative 4 times 0, that's 0. So that's just 0. And if I want the third derivative, what is that going to be? It's going to be positive 8 cosine of 2x. If my derivatives are okay, that's going to give me 8.
That one would be negative as well.
Wouldn't that be
You
negative
think so?
cosine?
Because this was really negative sine. So if I take the derivative of negative sine, I get negative cosine, which is going to give me that negative is going to give positive, isn't it?
Oh, the derivative of sine is just cosine, isn't it?
But it really is negative. It was really negative sine because remember we took derivative of cosine, which gave us negative sine. I just put it out in front of that negative 4.
Yeah, but then the 4 would remain. So if you did the
No,
derivative of sine, no,
that
so
is
if you took
true.
-4 as a
That's true.
factor,
So that's going to be negative, right? All right. Because if I bring that negative out in front, then I'm just taking a derivative of sine, which is cosine. Okay, I'll go along with that. That's okay. So that would give me -8 on there. All right. So now I can write out my polynomial function. 0 plus f prime of 0, so that's going to be 2x plus f, the second derivative, which was 0 again. So then that's going to be 0x squared over 2 factorial, which obviously is just going to be 0, plus -8 x to the third over 3 factorial, which is 6. So my answer, I would have 2x minus 4/3 x, 4/3 x to the third. So that would be my third degree polynomial. All right. Any questions on that? And Henry, you weren't here last week, so any questions on that?
yeah, I just misinterpreted the third degree for the 3 factor, 3.
Yep, and that is big because sometimes they'll ask you to do 3 terms. So if they ask me to do 3 terms, I'd still have to go one more out because the 0, these don't count because they're zeros, they're just gone. So I really only have a 2-term polynomial here, but I do have a third degree because it's x to the third. So I can stop.
Yeah, and I think when you mentioned that in the email you sent me, I was like, oh, that makes more sense now, because I was doing 3 degrees in 3 terms the same way, and I
Yep.
was looking at it and like they're using different like descriptors here, but I mean this like the same amount of answers, the same amount of terms in my polynomial, so that makes a
Yep.
lot more sense what you're saying.
Now, I did notice that you were struggling with problems that aren't at 0, okay? When they are not at 0, then we have to, it's exactly the same formula. So it's f of a plus f prime of a, but then this becomes x minus a, oops, in there, plus f double prime of a, x minus a to the second, all over 2 factorial. So all you're doing, instead of just having x there, you're going to have an x minus an a there, okay? And you weren't using that as your term. So in this problem, it says find the first few terms. We'll find the first 4 terms because this is pretty easy to take because it's e to the x, right? So I've got e, so I want f of 1 of e to the x, which is just e. Then I have f prime of 1 of e to the x. Well, it's all going to be e, isn't it? These are all going to be just e because the derivative is the same regardless of what you do. Okay, so does that make sense? That I just have e for all my terms.
Yeah.
Okay.
Yeah.
So now my first term is going to be e plus, and then it's going to be e x minus 1 because that's my a value, plus e x minus 1 to the second power, but now it's going to be over 2 factorial, plus e x minus 1 to the third over 3 factorial, and dot, 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 dot. Okay? So whenever it's not around 0, if it's 0, then you just leave the x in there. If it's a value, then you have to go x minus 1 in the parentheses. Does that make sense?
Yeah. I just think I totally just forgot about that segment. I mean, I remember that now because I
Okay.
watched the lesson. I just didn't remember it while I was doing the
All
lessons.
right. So Taylor and Maclaurin series are pretty easy. I'm almost guaranteeing that there will be a problem like that on this year's test. And the reason I'm saying that is because they skipped. If you took a look at what they didn't want us to do, they kind of skipped the parametrics, the polar coordinates, and all that. So that won't be on there this year. But they did want us to do Taylor series, so that means I'm almost positive they will be on there. let's take a look. This is 2017. I want to take a look at 2019 just because I want to make sure we get it in there. This was last year's AP test using or with the Taylor polynomial. Okay. Now, I think we did. Was this one of the problems on the assignment last week or not? Because it
I
will.
don't think so, but I think we did this in class last week.
Yes, and I think it'll be on this week's because I think this week's assessment. The only thing on this week's assessment, if you go into the exam, I think it was last year's exam. So this was last year's exam. I always, when they write the exams, they always have the same people writing them for like 3 or 4 years in a row. So they look very much the same. However, this year is going to be totally different because it's only 2 problems. I would assume that one of the problems is going to look very similar to this. And when you look at it, and you can use your calculator, you really can't use a calculator on this problem, can you? I mean, yes, you can do it. You're taking a test at home, but the calculator's not going to help you on a problem like this. So let's just take a look at this problem. Now, I believe that we can't do letter D because this is a convergence, and they didn't ask us to do convergence. They just asked us to be able to do a Taylor and a Maclaurin series. So convergence is not going to be there. All right, so let's take a look here. It says, write a third-degree Taylor polynomial about x equals 0. Whenever they say x equals 0, it makes the problem so much easier, I think, because you don't have to do as much. Okay, so I want a third-degree polynomial, so what I need is I need f of 0, I need f prime of 0, I need f double prime of 0, and it's a third degree, so usually I'm going to have to go down to the third degree here. Or third one. So now they give me a bunch of stuff over here that I should be able to figure out all of the values here. So f of 0, what is f of 0 in this problem? Yep. What is f prime of 0?
Negative 2.
Right, because you've got the tangent line there, so they gave us enough information. How about f double prime of 0?
3.
Yep, and now that's why they gave us this table. And f triple prime of 0?
Negative 23 over 2.
All right. So now if I want to write a Taylor series polynomial, pretty easy. My first term, 3, plus negative 2 times x to the first, plus 3 x to the second over 2 factorial. Well, 2 factorial is just 2, plus negative 23 over 2 x to the third over 3 factorial. Well, 3 factorial is 6, so this is just going to be 2 times 6 on the bottom, so 12. Done. Pretty easy problem. Didn't need a calculator. Calculator wouldn't have helped. So that's why I'm thinking a problem will be very similar to this year on the AP exam. All right. All right. Any questions on part A?
Nope, that makes sense.
All right.
No, that makes sense.
I want you guys to do part B by yourselves. It says write the first 3 non-zero terms of the Maclaurin series at x for y is equal for e to the x. Super simple, e to the x, because if you think about it, it's just going to be your first, everything's going to be 1, isn't it? F of 0 is going to be 1, f prime of 0 is going to be 1, f double prime of 0 is going to be 1. And then it says write the second degree Taylor. So let's do e to the x. It says write the first 3. Okay, so f of 0 equals 1. F prime of 0 equals 1. F double prime of 0 equals 1. And how many did they write? The first 3 non-zero terms. Okay, so this should give us 3 terms, right? So that's going to be 1 plus 1x plus 1x squared over 2. 3 terms. Now, What I want you guys to do is write the second degree Taylor polynomial for e to the x f of x about x equals 0. Okay? Much more difficult problem there, but that's the kind of problem that I think you're going to get this year. All right, so I'm going to turn off my mic. I'm going to let you guys work for a couple minutes, see what you get. All right, go to it.
Okay, I finished.
All right, give me your first two terms.
The first three you said, right?
Yep, but I just want the first two.
The first, oh, sorry. Okay, 3 plus x
That
are
was
the
it?
first two. That's my first two.
Okay, give me your third.
X squared. Or 2x squared over 2 factorial.
Which would just be x squared. Okay. Henry, do you agree?
I haven't gotten that far yet. I'm a little confused about the so I'm guessing e of x is e of x, e to the x times f of x is equal to f of x within the formula.
Well, okay. So what they're trying to get across here is that whenever you write a Taylor polynomial out, the first thing you really should do, so let's call this h of x. It really doesn't matter what we call this. So you're going to need to know what h of 0 is equal to. Well, if we put 0 in here, e to the 0 is going to be 1, right? F of 0, well, we know f of 0 is 3, right? So h of 0 is 3. But now we need to know what h prime of 0 is. Now that's a little bit tougher because that's going to deal. Now we're going to be dealing with the product rule, aren't we? Because we've got a function that has really two functions in it. So I would write this out as u is equal to e to the x, u prime is equal to e to the x, v is equal to f of x, v prime is equal to f prime of x. Do you understand what I'm doing here? Because we need h prime of 0. So we've got to find the derivative of this. Okay, well, the derivative of this is what? Inside. So I've got e to the x. I'm writing all over the place now. F of x plus e to the x f prime of x. But this is at 0, right? So if I put a 0 everywhere, all right, so that's going to be 1. F of 0 is 3. So this gives me 3 here, plus e of 0, that's 1 again. And then f prime of 0, well, over here we know that's -2. So that's going to be -2. So I've got 3 plus -2, which is 1. So now I know what h prime of 0 is equal to. So I've got my first two terms, then h double prime of 0. Well, guess what? I'm going to have to take the derivative of this thing, which is a pain. However, we know, we already know what this is, right? Because we already took the derivative of this part, and we came up with 1, right? So we have to be smart here. We already know what the derivative of this is because we already took it. It was right here. So this part is 1. So I'm going to have to put that down to the bottom. So that's 1. I still need to take the derivative of this. So u is equal to e to the x. U prime is equal to e to the x. V is equal to f prime of x. And v prime is equal to f double prime of x. Okay? And I can just put zeros in here right now. So this is 1. This is 1. F prime of 0 is -2. And f double prime of 0 is 3. So if I did inside, so that's -2 plus outside, so that's 3. So that gives me 1. So now I have 1 plus 1, which is 2. So that is why I think a problem like this is a good bet next week, because you can't use your calculator on this, but boy, do you need to know a lot of stuff. You need to know how to take the derivative. You have to be able to look at that graph and be able to find the values. That is why I think this is a perfect problem for them to put on the exam next week. I could be way off, but in my mind, this is the type of problem that it's like, yes, you're showing that you know how to take derivatives, product rule, Taylor series, they're all there. So Caleb, I would say that yes, your answer was 100% correct. 3 plus x squared. That is absolutely the correct answer for the third degree or the second degree polynomial there. Very nice.
Coolio.
Okay. Now, part C, it says let h be the function defined by h of x is equal to the integral. You can take the integral of a Taylor series, you can take the derivative, but it's, so f of t, well, that was right here, right? This was our f of t, okay, because that was part A. It says use a Taylor polynomial, find in part A to find an approximation of h of 1. Well, guess what? I can take, so that's the integral from 0 to 1 of f of t, so I can take the integral here. So that's going to be what? 3x plus negative 2x to the second over 2 plus 3x to the third over 3. And I'm going to stop there. I'm not going to do this one because I don't want to deal with that negative 23rd. But if you take a look here, and then you'd have to put your, because we took the integral, so that's from 0 to 1. And those cross off, so you're really left with 3x minus x squared plus x a third on the integral from 0 to 1. Plug the 1 in there, plug the 0 in there. So now you're showing them that you know how to take an integral, plug the value back in. So that is why I'm looking at this problem and thinking this is where I think they're going this year, because they know that you have calculators, but you can't use a calculator on any of this stuff. There's no way. I suppose you could have plugged this into your calculator and, you know, crunched out, you know, had your calculator spit out a number for you for an integral. I suppose you could do that, but, you know, it's easy enough to do without a calculator. All right, any questions on that? That is a problem that you're going to have this week on your assessment. Okay, it is, because I just took the 2019 AP test and I just put that as your assessment for this week. So any questions on any of that?
Nope, that makes sense.
Okay. Henry, okay with that?
Yep, I think I got it now.
All right. All right, so that I think is a good problem for this year. Another one that I wanted to go through is this problem here. This was last year's also, okay? And the reason I'm going through last year's problem is because, you know, whatever they did last year, most likely that's going to be very similar to this year's. Okay? So this problem I looked at and it's like, well, that's a pretty difficult problem. You really can't use it, again, you really can't use a calculator, but does it, when you think about this problem, it asks a lot of different things. I mean, you have to know how to do a lot of stuff, and we'll go through this problem and I'll show you why you need to know a lot of stuff. Okay, so let's take a look at this. It says consider the family of functions f of x equals 1 over x squared minus 2x plus k, where k is a constant. Find the value of k such that k is greater than 0, such that the slope of the line tangent to the graph of f at x equals 0 is equal to 6. Whew. Okay, so we have to find the value of k for the slope of the tangent line to the graph of f of x at x equals 0 equals 6. Okay, it's a kind of a crazy problem. I'm gonna turn off my mic. I'm gonna let you guys work at it because this is probably the first time you've seen a problem that looks like this. What I will say is that you're probably gonna have to take a derivative, right? You're gonna have to set that derivative equal to 6 and then plug in 0 for x and try to come up with your k. Okay, so I'm gonna turn off my mic. I'm gonna let you guys work for a couple minutes and see what you got. All right. What does k equal? All right, Caleb, what does k equal?
I got the square root of 1/3.
Yes, it is.
Wow, that's a brutal answer.
I got the same thing.
The square root of 1/3. The square root of 1/3. I'm not going to go with the square root. I had 1 over the square root of 3, which really isn't the square root of, which you could rewrite as the square root of 3 over 3. So you guys were really close. So what did you have again? The square root of 3 or the square root of 1/3?
The square root of 1/3.
Okay, that is the same. That is absolutely the same. Yes. So the square root of 1/3 is correct. You want me to go through how to get it? But because both of you guys got the same answer, right? Very nice.
Yeah.
I thought that was a tough problem. However, the next one's even tougher. The next one, I will just walk away, drop the mic, and walk away if you guys get this next answer, because this one is brutal. All right. For part B, it says for k equals -1/8. All right, so they're telling us what k is equal to. All right. It says find the value of the integral of 0 to 1 of f of x. So really, what they want you to be able to do is they want you to find this integral. 1 over x squared minus 2x minus 8. Can you find the integral of that? And if you can find the integral of that, I will say that you are amazing. But I'm not thinking I'm going to have to say that today. I could. All right, I'm going to turn off my mic. I'm going to let you work for a couple minutes and see what you get there. As I said, if you do get it, you really have mastered a lot of the stuff that we've done this year, because this is not a very easy integral. All right. Does anybody have an answer?
Can you distribute a -1 power?
Sure.
Okay.
No. You're a -1 power? No, you can't.
I don't know how to solve it.
Yeah, I see where you're going, Caleb, but I have no idea how to just.
All right. You guys are going to kick yourselves when I show you. And I forgot what this is called. But remember this when we did. So what I'm going to do is I'm going to factor this to be x minus 4x plus 2. Is that okay? And then I'm going to rewrite it like this. I'm going to go a over x minus 4 plus b over x plus 2 is equal to 1. And then remember how we cross multiplied here? So we ended up with a x plus 2 plus b x minus 4 is equal to 1. Then we multiplied through with the a, so I came up with ax plus 2a plus bx minus 4b is equal to 1. We got all of our x's on the same side, so I'm going to work down here. So I ended up with ax plus bx plus 2a minus 4b is equal to 1. Then I factor an x here. So a plus b plus 2a minus 4b is equal to, and I'm going to write this a little bit different. I'm going to rewrite it as 0a plus 1, or 0x, I'm sorry, 0x plus 1. So now I know that x, or my a plus b, is equal to 0, and I know that 2a minus 4b is equal to 1. So now I have to solve for a and b, because I need my a and b values here. So I'm just going to multiply through by 4 here. That gives me just 0 here. If I add down, I end up with 6a is equal to 1. a is equal to 1/6. If I know a is equal to 1/6, I can just plug it back in here. A plus b is equal to 0, so b is equal to negative 1/6. So now I have the integral of 1/6 over x minus 4 plus negative 1/6 over x plus 2. So now I can take the integral of each one of these. It would be 1/6 natural log of x minus 4 plus negative 1/6 natural log of x plus 2. Boom. Do you guys remember what that was called? When we split the fraction up like this?
No, but I totally forgot that.
Yeah.
Yeah, when I took a look at this problem, I am sitting there thinking, there's no way I can take the integral of this thing. And then it's like, oh, I remember when we split these things up, and a lot of times we had like 2x up here, and we'd set it equal to 2x, and then we'd, the a plus b is equal to 2. But I forgot what that was called. But it's one of those things where it's like, yeah, you definitely could not use a calculator on that, could you? There's no way that you could use a calculator there. So these are the types of problems, if you had to come up with it during an exam, I'm not so sure. Now, do you guys remember doing these types of problems?
Yes.
Yes, I do remember them.
Okay. Do you want to try another one?
Yeah.
Yeah.
Okay. Well, I have to just make it up. Okay, so if I erase this, let's say we want to take the integral, and let's say we want to take the integral of 2x plus 4 over x minus, I'm just making this up, so it might turn out nasty, an x plus 4. Okay? So try that one. I will try it at my seat and see what you get for an integral, okay? That way at least we'll remember how to do this type of problem. All right, I'll do it at my seat. You guys take a look at it and see what you get. This thing doesn't work out bad at all.
Oh, really? Oh, then
Yeah.
I'm not doing this right.
I got a pretty nice answer. Now, I'm not sure if I did it right, but I think I did. All right, who said that they didn't? Was that Caleb or was that?
Well, it's Caleb. I just found A and B.
Okay, what did you get for A?
Negative 4/7.
No, that's not what I had.
Okay.
And maybe I just wished it into nice numbers.
I got relatively nice numbers. I mean, I got fractions, but they're not like
Oh, did you? I didn't get
horrible.
fractions. What did I mess up on? Okay. -3, 4. All right. So let me work it out on the board, because I thought I had nice numbers, but since both of you guys came up with not so nice numbers, so if I was going to do this problem, I would do a x minus 3 plus b x plus 4 is equal to 2x plus 4, right? And then I cross multiplied here, so I ended up with ax plus 4a. Oh, that might be where I made my mistake. Oh, no, I didn't. Plus bx minus 3b. So far, so good?
Yeah.
Okay, so then I brought my x's together. So then I ended up with x a plus b is equal to, what is that, 4a, plus, I'm sorry, plus 4a minus 3b is equal to 2x plus 4. So then it's like, okay, so now I know a plus b is equal to 2, right? And I also know that 4a minus 3b is equal to 4. So far, so good?
Mm-hmm.
Now I use the addition method, so I just multiplied through by negative 3. And negative 3 times 2 is negative 6, right? So if I add straight down, I ended up with 1a is equal to negative 2.
I think I see where you did it. So
Oh goodness, and I messed up.
see, no. So see the you multiplied by -3 when you should have multiplied by +3. Because by making it a -3,
Oh, right,
yeah,
right.
that's what I did.
That's
So I got 10
positive 3.
sevenths A,
All right, all
10
right.
sevenths is A, and then 4 sevenths is B. So it's 10 over 7 times the natural log of x minus
All
3
right.
plus 4 sevenths.
Okay, so I did wish it into a nice number. All right, so you had A is 10 sevenths,
Yes,
and then B would equal, well, 10 sevenths plus what gives us,
4 sevenths.
what was it, 4 sevenths?
Yeah,
All right,
because A plus
so
B is
then,
2.
yeah, so then the
Oh
answer
yeah,
is just 10 sevenths natural log of x minus 3 plus 4 sevenths natural log of x plus 4.
agreed. That's what
Yeah.
I got.
Okay, all right.
How did you get a negative number, Caleb?
Because I randomly decided to change x to be equal to 0, and so instead of getting I got b equals 4 sevenths, but then I set a to equal -4 sevenths instead of to equal 10 sevenths because I made a mistake.
Yeah, and when I was doing it, I just wished it into having those B's cross off, and it's like, oh man, this is not bad. 1A is equal to that, not bad. All right, but that is a quick review of, and I wish I remembered what this was called, but I don't. Um, but it is one of those integral rules that you can't use a calculator, right? I mean, there's no way you could have used a calculator to find 10 sevenths natural log of x minus 3. It just doesn't work. That's why, the people that write these AP tests, they're smart. They understand where you can use a calculator and where you can't. You can't use a calculator on this type of problem. Okay, now part C, again, you probably don't remember this. I'm just gonna say it. You probably won't. In this problem, now they're telling us k is equal to 1. Okay, that's it's good. They told me what this is equal to. So now if I factored this, I end up with the integral and from 0 to 2. But guess what? If I put 1 in here and I factor this, I end up with x minus 1 quantity squared, correct? Okay. So each time they're changing what the k value is. So what is so hard about this problem? Well, guess what? I'm kind of thinking what the graph looks like. The graph of this thing, I've got x minus 1. That means at positive 1, there's an asymptote. This graph probably looks something like this, doesn't it? So in this problem, we have a problem at 1 because they want the integral from 0 to 2 of 1 over x minus 1 squared. Well, we did problems like this year. We broke it up. We said it was the limit as b approaches, we would have broken that up to 1, right? So this would be 0 to 1 of 1 over x minus 1 squared plus the integral from 1 to 2 of 1 over x minus 1 quantity squared. Okay, do you guys remember that? If you're going to a function like that, okay, you've got to split it up. Now, when you do this, when you take the integral of this problem, I do believe you're going to end up with something like, if I do this right, I think it's the limit as b approaches 1 of, and if I take the integral of that, what do I get? Negative 1 over x minus 1. Is that right? And then plus, and then I'm going to have on the other side, I'm going to have the limit as b approaches, and this is from the left and right. That's going to be negative 1 over x minus 1 again. But when you plug it in there, you're going to have, it's going to diverge because it's going to be undefined when you plug 1 in. So it's going to be diverges because you plug the 1 in there, it's still going to end up being undefined. So it's going to be a divergent series. But what I wanted to do is I wanted to get across that point of taking the integral where there's a vertical asymptote, so that function is going up to infinity. Okay, does that ring bells?
Mm-hmm.
Yes.
All right. Whew, okay, we still have about 14 minutes. I think there was one other problem that I wanted to go through that. Okay, this problem here, almost every year there's a problem with a graph on there. Usually it's a derivative graph, but this one is not a derivative graph. But again, there's a lot of stuff on here that you can't use calculators on, and that is what I'm trying to get across is, yes, you can use calculators on this test. They can't stop you. They're not going to be in your room. Yeah, both of you guys took the test last year, correct?
I did not.
Oh, you did not?
I did.
Yeah, and you sat in a room and they took your calculators away, right? And then they made you do one part of the test, and then they gave you the calculator, and you use the calculator on the next part. Well, this year there is nobody going to be taking your calculators away, so you have the right to use your calculators. But you get a problem like this, your calculator is not going to help. So let's take a look at this problem. It says that you have a continuous function f is defined on the closed interval between -6 and 5. The figure above shows a portion of the graph of f consisting of 2 line segments and a quarter of a circle centered at the point 5, 3. It is known that the point 3 minus the square root of 5 is on the graph of f. So 3, so this point right here is 3 minus the square root of 5. All right, so in part A, it says, if the integral from -6 to 5 of f of x d of x is equal to 7, find the value of the integral from -6 to -2 f of x d of x. It's a tough problem. I mean, this is not. I mean, I looked at it and I was like, oh, that's pretty easy. I'm just taking an integral, but you're looking at this thing. This is from -6. You don't even know what the graph looks like from -6. It's from -6 to 5. This graph is equal to, or the area underneath the graph is equal to 7. From -6 to 5. So now they want you to figure out what -2 to 6 is. So guess what? You're just going to find the area underneath here and then subtract it from 7, and you should get the area of this, right? It's a pretty interesting type problem. I struggled with this one for a while. I mean, because now you've got a semicircle here, so you've got to find the area underneath this curve. Well, you've got to find the area of the square. Well, the square is 9 minus the circle, and only a fourth of the circle. Well, the radius is 3. 3 squared is 9, so that's 9 pi over 4. So just this area right here is 9 minus 9 pi over 4. That was kind of crazy. right? So what I'd like you guys to do is I'd like you to take a little bit of time, see if you can get the answer for number 3. See what for part A, and then we'll do part B together. All right. Any answers?
I have an answer for the integral from -2 to 5, which is basically what we're looking for. I just didn't subtract it from 7 yet.
Okay, what did you get?
11.5 minus 9 pi over 4.
11.5 minus 9 pi over 4. I don't think I got that. And I've made mistakes before. Caleb, what did you get?
That was Caleb. But
Oh, I'm
Henry.
sorry. Henry, what did you get?
I got 13 1/4 minus 9/4 times pi.
All right. Maybe I messed up. I thought I had 11 minus 9 pi over 4 for my integral from -6.
You're right. You're right. I missed a -1/2. You're right. It's 11.
Okay. Whew. Okay, so I ended up with, I think I ended up with like 7 minus 11 plus 9 pi over 4, something like that. So I think I ended up with 9 pi over 4 minus 4 for my total answer. Okay, because I ended up, well, all of this was 2. So that's where I came up with this 11 minus 9 pi over 4, because I ended up with, this was the 9 pi, or 9 minus 9 pi over 4, but all of this, I came up with 2. So then I ended up with 11 minus 9 pi over 4, and then I ended up with that 7 minus that. So I ended up with 9 pi over 4 minus 4. Okay, does that make sense?
Yeah, I just forgot to divide by 2 when I found the area under
Okay.
1/2 2.
So now part B, it says that they want us to find the integral from 3 to 5 of 2 times f prime of x plus 4. Now, again, can't use a calculator, but this problem, when I look at it, it's like, I'm looking at it, it's like, okay, I'm going to just do the integral from 3 to 5. Oops. I'm going to pull the 2 out to the front of f prime of x plus the integral from 3 to 5 of 4. To me, that makes a lot of sense. I'm just using the rules to break this thing up. Well, the integral of 3 to 5 of f prime, isn't that just f of x from 3 to 5? So isn't that just f of 5 minus f of 3? And then and f of 3, that's why they gave me that f of 3, right? That's 3 minus the square root of 5. And then f of 5, it looks like 0, doesn't it? So this is going to be 0 minus 3 minus the square root of 5. So this is just going to end up being -3 plus the square root of 5, if I'm not mistaken. And then I still have a 2 on the outside. So that's going to be 2 times -3 plus the square root of 5. But I still have the integral of this, right? So that's going to be, what, 4x 3 to 5. That's going to be 20 minus 12, which is 8. Is that plus 8 there? So negative 6 plus 2 square root of 5 plus 8. So 2 plus 2 square root of 5. Oh, I think that's right. Pretty interesting types of problems. I mean, without having to be able to use a calculator, they're asking you so much in these types of problems. Do you guys get where I came up with the 2 square root of 5 for an answer?
Yes.
All right. I'm gonna skip C. I'm gonna go all the way down to D. It says find the limit as x approaches 1 of 10x, 10 to the x power minus 3 f prime of x over f of x minus arctangent of x. All right, I want you to give me that answer, and that is going to be our last answer of this semester. Guys, do a lot of studying this week, but on the weekend, stop. You can work too hard sometimes and study too long. You will find that all of the problems that we did today are on the last year's assessment or last year's AP exam, which are on your weekly assessment this week. Or it's not even an assessment, it's just a AP exam thing. So you guys should be almost done with this week's stuff. I do have a button in the course. It is called, let me jump in there again. There's a button in our course. It is called Previous AP Tests with Answers. Look at it. It's got all of the answers for like the last 3 years. Those are some good problems, and that is a good thing to have when you're taking the exam, because you can see how the answer keys are. All right. Letter D. See if you guys get the right answer. All right. Who's got the answer for letter D?
I just have no idea how to do the arctangent thing.
Arctangent. Oh, was this a calculator? This is no calculator problem. Arctangent of 1. Yeah, how would you do that without a calculator? Because I just know that arctangent of 1. Okay, that's a terrible 45 degree triangle, right? 45 degree triangle. If this side was 2, this side would be 2, this side would be 2 squared of 2, right? Do you agree with that?
Yeah.
Yes.
Okay. What would the tangent be of 45 degrees?
Oh, 1.
Yes. So the tangent of 1, the arctangent of 1 is 45 degrees, or pi over 4.
Okay.
So that's going to be pi over 4.
Gotcha.
And if you didn't know that fact, and that was on an AP test this year, you'd just use your calculator, right?
Mm-hmm.
Because they are not telling you can't use a calculator. I mean, it might say no calculator up here, but they can't do that this year. All right. So what is my answer? What's the top?
I got 17 divided by 2 minus pi over 4.
17? Where did you get 17 from?
Oh. I don't know.
I think it's
Oh, wait.
16.
16? Where did you
No,
get
no,
16
no,
from?
no. Sorry, 4.
All right, I came up with
Oh
4.
my. Oh my.
I'm just plugging 1 in here. I get 10 to the first minus 3 times f prime of 1, right? Well, what is f prime of 1 in there? Isn't that just
2.
2? Here's 1. That's
Oh,
still,
my goodness.
yeah. So that's just 10 minus 3 times 2, which is 10 minus 6. Top is 4. and then f of 1 is that just 1? So on the bottom, I just ended up with 1 minus pi over 4. That was my answer for that one. Okay. So now I don't know. So here's, and this is, if you took a look at that link, here is, if you ever find a problem that looks very similar to it, that's why the answer keys are so nice, because they show you how they want you to do the type of work here. And sometimes looking at an answer key, it's like, oh, that's how they wanted me to do that problem. Okay, I don't know. Let me jump way down to, yeah, okay. So here's that one problem that we started off with, with the 1 over x squared minus 2x plus k. Here's the answer key, and here's, so they do show you how to do that, kind of a review of solving those types of problems. So sometimes answer keys do help you figure out what you're doing there. All right, gentlemen, it was good having you in class this year. Good luck on the AP exam. When you are done with the AP exam, could you just write, just email me and just tell me how it was? Because it is totally different this year. I'd love to know what you guys thought of the test this year, because I'd love to know what it looks like. I know somebody will have it posted within 3 days. I mean, somebody always gets the test, and they always post it online. So I'll be able to figure out what the 2 problems were. But just send me an email. Just tell me how you thought it was.
Yeah, definitely. Thank you so much, Mr.
Thank you.
Franklin. It's been a great year.
And remember, no semester exam this year. So once you guys are done with your AP test, you are done. So enjoy the rest of the year. All right.
Thank you.
Thank you.
All right. See you guys.